This will be the sixth video of the tutorial of Amira, and we will discuss on how to work with the segmented materials and on how to export the segmentation into different file formats that are useful in for working with them in other programs. So first of all, we have finally we can assume that this is our final segmentation. So we have a part of the skin, a part of the bone, and finally the muscle. Okay, so these three materials. Let's say that this is an example of our segmentation. So first of all, an interesting thing to know is that this is a label field. Okay, we can create a new label field. Let's say like a new where we can perform a sort of new segmentation. But the interesting thing is that we can go back selecting load zero labels, and we can, for example, select the skin and then change the label, and we will we are able to basically transpose it, so transport it to also this other label field. So for example, you add the material to the inside, and now we have a label field that has only the skin in it. And this could be useful, for example, if you want to extract a bone. So for example, from the rest of the segmentation, and maybe create some masks with the techniques that I'm going to describe now in how to export different files. So this is something interesting that can be useful in some cases if you want to create different labels that have different parts segmented in it. So once we have finished the segmentation, we can go to project, and we will find our labels over here. So here you have a sort of preview. So this is the complete part that we have done, and this is just the new label, but we will work with load zero in this case. So if we go straight to, for example, generate surface, and we apply, we will see that this will tell you that this might result in a rather big surface, because yeah, there are a lot of voxels, and so it gives you this warning. So to reduce the size, they suggest you to use a tool that is called resample. That is this one. However, before this tool, an useful thing to do is to separate the different. No, let's go first with resample. So here you have a sort of averaging feature where you can actually, I think that like this, you divide by 2 the voxel in each of these dimensions. So you strongly reduce the dimension of the overall file that you are working with. So we can apply. So we have a new load zero resampled in this case. And at this point, there is another useful tool that is called the arithmetic. This tool allows us to separate different regions, the different segmented regions. So it works like this. So we can go back to the segmentation 1 second, and we need to check. So exterior will be number 0, so exterior number 1, and then skin number 2, 3, and 4. So 2, 3, and 4 are the actual materials that we are interested in. So we can go on arithmetic, and here we put A equal to 2, and this will actually select the skin. Okay, so here, okay, the skin that is 0, 1, 2. This selects the skin, and finally, what we can do is that we can generate our surface. And over here, we have this part that actually asks about eventual smoothing, okay? So you can either don't put any smoothing. No, sorry. So unconstrained smoothing. Let's start with unconstrained smoothing and see what happens. So you apply, so this will generate a surface. And then finally, to see this surface, we need to go on surface view and create. Okay, so this is our skin. It's quite bad, as you can see it. Let's remove this ortho slice. This is because there is some smoothing applied over here. Okay, so this is 5. So if we don't want any smoothing, let's see how it comes out. It comes out like this. So a little bit like Minecraft stuff. Okay, something. Of course, we don't want this, so we want a sort of something in the middle. So what we want to do is, so there is a difference between constrained and smoothing and unconstrained smoothing. Let's check first unconstrained smoothing. That was the one that we had before, but we want to reduce strongly the amount of smoothing that we are applying. So apply, and yeah, we are getting something that is a little bit better. So we can maybe still increase a little bit. Okay, so it's getting a little bit better. Okay, so let's do it even more. You can see, according to, well, the skin is something very challenging in this. So if you are segmenting something different, perhaps you will get some much better results. However, the issue is that unconstrained smoothing does not take into account the other materials that we had over here. Okay, so for example, if we go back here and we do another arithmetic in order to select, for example, the bone, okay, and well, let's do 3 of them at this point. Okay, so this one will be a equal to 3. This one will be a equal to 4. So what? Yeah, wait. So you will see that over here, these two surfaces actually do not match each other. Okay, so there is a hole in here, and they are totally defined on different points. But so what we don't want, in general, we don't want this. We want surfaces that are lying on the same point. So what we need to do is actually what is called constraint smoothing. Okay, so constraint smoothing is will fix the points in the interfaces between the different materials. Okay, so now it's a little bit hard to see it over here, but but they are actually all defined in the same points regarding the interactions between the surfaces. Perhaps the best option is to remove smoothing at all. Let's check. Yeah, maybe this is one of the best option in this case. Yeah, you still get, well, you can play around a little bit with these things and see what is the best option for you. And finally, what we can do is there are different types of file that can be interesting. Like, for example, one of them is the um, the raw label images, so the binary images. Okay, so what we go here, and then we go on this arrow, and here you can save in different formats. So the one that I'm talking about is Analyze 7.5 HDR, and we can save it, for example, in Amira tutorial. This will create these two files, and these ones can be, for example, implemented in shown very quickly into, for example, 3D slicer. And can well, that is the same principle, like im.img file contains all the information, while like all the data, while labels is actually telling you how to read these data, these images. Finally, we have the possibility to export our surfaces over here. And here we can export in STL. This is very common, or also OBJ files that are very common. So, for example, this one, and we get it over here. So this concludes a little bit our tutorial. Definitely. You might find out some additional tricks and maybe some ways to do things faster and easier. So my suggestion is if you can just make another video and add it to this list, so then the next students will be able to also have your advice in this stuff. And yeah, thank you for your attention.